All right, this is Chapter 7, Section 5, Proportions in Triangles. And here's my little diagram to go with the topic. Our objective is to use the side splitter theorem in the triangle angle bisector theorem. So if we look at all of our important information, Theorem 7-4 is the side splitter theorem. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So, for example, if RS is parallel to XY, then XR and over RQ is equal to YS over SQ. And then the side splitter, corollary to the side splitter theorem is if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So if we look here, AB is right here, BC is here. Those two sides are proportional to WX over XY. So the sides end up being proportional. So we're going to take those items and we're going to solve a triangle and then solve a three parallel lines problem. So if I'm looking at number 11 here, we're going to solve for x. So I'm going to use the side splitter theorem. So if I were to transfer that here, this is my RQ, and this is my RQ, and then this is my XR. So we're going to say X over X plus 5 is proportional to YS, so the little guy here, 8, over 12. So before I start manipulating, I know 8/12 reduces because 4 goes into 8 and 4 goes into 12. So I'm going to reduce that first. So I'm going to say 8/12 is 2/3. That'll make my numbers a little bit easier. So I'm going to cross multiply. And so I get 3x equals 2 times x plus 5. Make that look more like a 2 and less like a 1. So that's 3x. I'm going to distribute out the 2, so that's 2x plus 10. Subtract 2 x's from both sides. And I get x is equal to done. And just for fun, x plus 5 would be 15. All right, so that's side splitter. Let's see how to apply the corollary to the side splitter. So my entire length here is 24. This little piece here is x. This here is 8, and this here is 12. All right, so we are going to, unfortunately, we can't go x and then this distance, although we can. Okay. So we're going to say that 8 over x. So this and this is going to be equal to this over, well, the whole distance is 24. So this little distance from here to here has to be 24 minus x. So now I have a nice little proportion. All I have to do is solve. So 8 times 24 minus x equals 12x. Eight times 24 is 192 minus 8x equals 12x. And I'm going to add 8 x's to both sides. And I get 20x equals 192. And I divide by 20. 192 divided by 20 is 9.6. All right, before I let you go for sure, I want to just reiterate the triangle angle bisector theorem, which wasn't on the original one. If a ray bisects the angle of a triangle, then it divides the opposite sides into two segments that are proportional. So for here, it would mean, because this is a bisector, that CD over DB is proportional to CA over BA. And that's all for today.